let's take a look at your graphs. So you have drawn out the sine graph and the cosine graph. And let's make sure that we label and make sure we've done correctly your amplitude. So remember, this is my center line for my parent functions right on the x-axis. And my graph goes up to 1 and it goes down to -1. That's my amplitude of 1. Let's also look at the period of your graph and label that. Remember, for sine, we start on the y-axis at 0. We go up, down, back up again, and when we hit that 0 again, it should be at 2 pi to show that period is 2 pi. Let's take a look at that again. So let me change colors so we can see a little bit better. So we start at 0 and we go up to 1. On our way down, we pass through 0 again, go down to -1 and come up to 0. Notice that pattern. Everything is happening in half a pi. So the distance between the maximum and the x-intercept is pi over 2. The distance between the x-intercept and the minimum is pi over 2. So notice those patterns and the rhythm of the graph. It'll help you to graph it more accurately. We can see that our x-intercepts happen at pi, at 2 pi, at 0. So the distance between all of these x-intercepts is pi. So if I were to keep going, I could assume there's one at 3 pi and 4 pi and 5 pi and 6 pi. So the way that we typically write that is we take our first one, usually not one on the y-axis, and we say that your y-intercepts are every pi plus pi n, because this is the distance between them and this is the very first one. I could put a 0 there as well. Let's look at your cosine graph. So cosine starts at +1 and it goes down in a distance of pi to -1. Notice it passes through the x-axis on its way. Then at 2 pi it lands at 1 again. It passes through the x-axis on its way. So same pattern. The distance between every maximum and x-intercept is pi over 2. The distance between every x-intercept and minimum is pi over 2. This pattern holds. So if I look at x-intercepts for the cosine graph, my first x-intercept is at pi over 2. My second one is at 3 pi over 2. What is this distance? It's a distance of pi. So we can say the same thing, that the x-intercepts are every pi over 2, but they're spaced out every pi. So let's look at how can we graph these functions if it's not the parent function and there's transformations that are occurring. Well, the first thing we're going to want to do is find our amplitude. Again, amplitude is just going to be the number in the front of the function. Second thing we're going to do is find the period of our function. The period is 2 pi over b. So we will have to work with some fractions and divide to find the period of the function. So how frequently is it repeating? Then we're going to look for any phase shifts. Okay, that'll help us to identify where to start our graph, okay? Because sine typically starts at 0, 0, right? But if we have a phase shift, if it's getting shifted over, we'll have to put that intercept over whatever that distance is. And then finally, we'll look at our vertical shift. That will help us to know if it's centered on the 0 line, just like all of the other ones we've seen so far, or if we need to move it up or down and center it somewhere else. Once we get all of these things labeled on our graph, then we'll fill in the curve. So today's video is going to be a little bit longer than normal because I want us to do a bunch of these together because I know that this is new for you. So at any point, if you need to pause it and take a break and come back, obviously that is understandable. So let's start with this first one. Y equals 1/2 sine x. So first thing we're supposed to look for is the amplitude. Remember, the amplitude is the number in the front. So our amplitude is 1/2. Next thing we're going to look for is the period. Do you see a number in front of the x here? No. So the period is just 2 pi over 1. We don't see a number in front of the x. Well, the number that's hiding is a 1. The period is just 2 pi. Nothing has changed from the parent function. The parent function has a period of 2 pi. This does not have a b value in front of the x, so the period of this function is 2 pi. All right, so let's graph this. Sine starts at 0, 0, and there are no shifts left and right, so I'm going to put a point at 0, 0. Then sine goes up, and it goes up to its maximum point at pi over 2. The maximum of this graph is going to be 1/2 because that's the amplitude. So I'm going to go up to 1/2, and then I'm going to start heading down. On my way down, I'll go through the x-intercept at pi, and then I'll reach my minimum of -1/2, and I'll reach that when I'm at 3 pi over 2. And then I'll come back and land on the x-axis again at 2 pi. Now I can draw in my curve. So I go up, down, and back up again. So notice there were some things I needed to rely on to do that. I had to know where does sine typically start and what direction does it go from there. So if you don't remember that yet, make sure you have your parent function sitting out next to you so you can look at it and know where I'm getting those things from. Let's try another one. This time we're going to graph a cosine function, and I see more transformations happening here. First thing we check though is the amplitude. Amplitude is the multiplier in front. I see two things with this amplitude. I see a negative sign. Remember, negatives in front mean a vertical reflection. Oops. Or a reflection over the x-axis. So we're going to flip this one. The other thing I see in front is that 2. So that means my graph is going to go up to 2 and down to -2. This time, I do see a number next to the x. I see the number 4. That's my b value. So what I need to do to find my period is it's 2 pi over 4, or the period is equal to pi over 2 if I reduce that fraction, if I reduce 2 over 4. Now that I have those things figured out, I'm ready to start labeling some points on my graph. Remember, cosine parent function typically starts high and goes down, but we have a reflection, a flip. So we're going to start low and go up. I'm going to start at -2. And the period of this graph is pi over 2. That means I'm going to hit -2 again at pi over 2. It's going to take me that distance to do a full cycle. Well, in the cosine graph, if I've got a minimum at the beginning and a minimum at the end, that means I'm going to have a maximum here in the middle. My middle value is pi over 4, so I'll have a maximum right here. And then I'm going to pass through the x-axis on my way. So now that I have my points labeled, I can go up, down, and back again. And that's a picture of my -2 cosine of 4x function. Let's try a couple more. Cosine of x minus pi over 2. So we're looking at cosine. I don't see an amplitude change, so I know it's going to go from +1 to -1. I do not see a number in front of the x being a multiplier, so I know that my period is just going to stay 2 pi. The only thing I see is this right here. That's a horizontal shift. Remember, we call that a phase shift. That's our vocabulary term for that. So my period is going to remain 2 pi, and my phase shift is going to go right pi over 2. So typically, again, my parent function starts at 1, goes down and back up again. But I'm going to take that maximum point that usually starts right here, and I'm going to shift it over to the right pi over 2. Everything on my graph is going to get shifted over pi over 2. Every intercept, every maximum, every minimum. So to start graphing this, normally I would start at the 1 for my cosine function, but I'm not going to do that right now. I'm not going to start at 1. I need to shift it over to pi over 2. Now, I'm going to go down through my x-axis. I'm going to bottom out, come back up through my x-axis, and go back up to 1 again. So this is a pi over 2 right here where my first point is. This is a 3 pi over 2. This is a 5 pi over 2. Notice the distance between my first point and my last point is 2 pi. I kept that period of 2 pi when I did this. Let's finish up our graph. If this is a maximum, let's fill it in actually first. I'm going to draw my curve. Notice what would happen here. I would come down. And this would come down. What does this graph look like to you? It's starting at 0, 0 and going up, down, up. It looks just like the sine graph, doesn't it? We can use phase shifts to move between cosine and sine graphs. If you were to go to Desmos right now and type this graph in, this function in, cosine of x minus pi over 2, and then right underneath it type in sine of x, you're going to get two graphs that overlay each other. Okay, so there'll be times if you're ever asked to write a function for, say, a real life situation, you could use cosine or you could use sine based on your phase shifts. Isn't that exciting? I know you're pumped. Okay, let's look at one more example, and one that uses a phase shift because I know that those are a little trickier. And then we'll take a break and do one word problem, one application. Okay. All right, so let's get started with this problem by identifying some key points. So first of all, A, amplitude. Look at the front of your function. I don't see an amplitude change, which tells me the amplitude is 1, but I do see a negative there, so we're going to have a vertical reflection. So let's make note of that. Oops. Okay. Now we're going to check to see what the period is. I do not see anything being multiplied in front of the x, which means that the period is not changing, and our period is simply 2 pi. The last thing I see is pi over 4 being added to x. When I see that in the parentheses, I know that I have a phase shift. And in this case, the phase shift says plus, so it'll be left pi over 4. Going left pi over 4. Okay, so let's think about our sine parent function. The parent function starts at 0, 0, goes up, down, up again, and ends at 2 pi. So we're going to have to do two things to this function. We are going to have to flip it, and all flipping means is that we're going to go down, up, down. So we're going to just do the opposite order. And we're going to shift everything left pi over 4. So every point will go to the left just a little bit. If I look at the x-axis on my graph, it looks like I have every quarter pi labeled. So pi over 4, pi over 2, 3 pi over 4, pi. So we're set up to do this quite easily. So I'm not going to start at 0, 0. I have to shift this over and start at pi over 4. Negative pi over 4. I'm not going to end my graph at 2 pi. I'm going to end it pi over 4 left of that. My other x-intercept will not be at pi. Again, it's going to be left of that at pi over 4. Or 3 pi over 4. My amplitude's not changing, so that I know right in the middle of these 2 points at positive pi over 4, I'm not going to reach a maximum. Remember, we have that flip. I'm going to see a minimum of -1. And then, in between those other 2 points here, I'm going to see my maximum of +1. Now I can fill in my graph. Okay, take a break now, and then we'll come back and do one word problem together.